Hey guys, and happy Tuesday. Today we're going to talk about slope as we move into our new unit. I'm going to go ahead and kind of start talking about slope. This is something you've heard of before, how to find slope, and then move into linear equations that have slope in them. Don't forget your test is still Friday, so you're still going to be working on looking back over your notebook and your old notes for multi-step equations and inequalities. And multiple solutions and one solution and things like that. So on Thursday, I'll give you a review sheet for all of that for your test Friday, but there's really no more notes to talk about with that. We've gone over as much as we can. You're more than welcome to always do extra practice that you find online through Khan Academy. That's KHAN Academy. They have tons of practice. If you feel that you need more practice with multi-step equations and inequalities, you can always come into tutoring with me or set up a Zoom with me if you're confused on something. But it is time for us to start looking at slope as we gradually shift into our next unit that's coming up. So I started the notes for today, but I didn't finish them because I want you guys to watch me writing these out. I don't want it to already be written out, just because I don't want you guys to be lost. I want you to see the order that I wrote these things in. So we're going to start talking about slope and then prep us for our next unit, which we should go over linear equations a little bit more. So what is slope? Slope basically is just a word to describe how steep a line is that you're graphing. And so when we're talking about the slope of a line, right now I'm going to show you how to find it from ordered pairs or points that you've been given. But eventually you'll graph those points. You'll be able to connect those points. And when you connect those dots, you'll be able to see what that slope is. It might be, not very steep at all, almost like a flat line, but there is a little bit of a slope to it. Or it might be super steep and the slope might be massive. And you can graph your 2 points and see it, or you can use the formula that I'm going to show you to figure out what your slope is. And again, this is something you have learned before back in middle school, but we're going to start putting it all together and how to find slope, how to see the slope, and how to use slope to move when you're graphing. So today it's going to be the slope formula. So m is the letter that represents slope. So when we get into our linear equations, it's going to be y equals mx plus b. And that m lets us know what the slope is and how we move to make that line. And in order to find m, your formula is y2 minus y1 over x2 minus x1. So you're basically, I know you've heard this before, you're doing rise over run because your y values, if you're thinking about like a x and a y axis, right, on a graph, your x-axis runs horizontally, your y-axis rises up and down. So if you're talking about the difference in the y values, you're talking about the difference on the y-axis, which is your up and down axis, so what you're rising. If you're talking about the difference between the two x values of your points, you're talking about the difference between them horizontally, which is how far they are apart from each other on the x-axis, or imagine how far they run. So the y values are how far apart they are up and down, which causes you to rise. The x values are how far apart they are side by side, which is what we call running. So this is the formula you will use to find your slope if they've given you 2 points. And that's all you need is 2 points, and you can figure out your slope. And then later, once we graph it, we'll be able to figure out what our start point is. And you can write linear equations from 2 points after you graph it. So if I gave you these 2 points, and these are the examples, if you're wondering, well, what is y2 and y1 and x2 and x1? What are those? What you're going to do is you're going to take your ordered pairs that have been given to you and you're going to label them. So these won't be there. You're going to have to write those on there. This is my first ordered pair. This is the x and the y of that ordered pair. So we notate it x sub 1, y sub 1. So I know that this is the x value of the first ordered pair and the y value of the first ordered pair. And then because this is my second ordered pair, it's going to be x sub 2, y sub 2. So this just lets me know that this is the x and the y of the second pair. This is the x and the y of the first pair. So if I said, what's the slope of the line that runs between these 2 points, you can find it using this formula. So let's write it out. Now that we've labeled them, and that's always the first thing you do, we're just going to plug them in. y2 minus y1. Well, this is y2. This is y1. So I have 7 minus 2 over, and then it says x2 minus x1, which is 4 minus 5. Now, the key thing also to remember is this is a huge, huge, huge problem that I see all the time. If you start with y2 minus y1 up top, so I did 7 minus 2, then the bottom has to start in the exact same order. You have to start back here and do x2 minus x1. So if I go y2 minus y1 over x2 minus x1, they should line up. 4 and 7 are from the same ordered pair and they line up. 5 and 2 are from the same ordered pair and they line up. So that way I know that I'm going in the right order. You cannot do y2 minus y1 and then come down here and decide to go x1 minus x2. We can't do that. It's not going to work. You have to start from the same ordered pair every time. So start with the back ordered pair and go to the front, back to front. And then you just reduce this down. So 7 minus 2 is 5. 4 minus 5, since 5 is a bigger number, that's actually negative 1. And this can still be reduced. Okay, we know that any whole number is a fraction over 1. So I can just simplify that and just say, oh, that's just 5. But don't forget about this little negative symbol. It's got to come over. You can't forget about it. So that just becomes negative 5. That's our simplified answer. Now, the biggest thing to remember with slope is that when you go to graph it, keeping it like this will help you because you're keeping it rise over run. But if you see whole numbers, you should still be able to realize that that has a 1 underneath it. Okay? So if you're like, okay, I see one number and I know that I'm supposed to rise and then run, but I don't see another number. They're not going to represent whole numbers like this. They'll represent whole numbers like this. So you're going to have to realize that it is over a 1. And then the second thing that I want you to see in this example is that this one tells me to rise 5 and run negative 1. But this one tells me to go down 5 and run 1. So how are they the same slope, but it's written differently? Well, it doesn't matter which value has the negative sign here. I mean, it does when you're doing your math. Obviously, it was right here. This 4 minus 5 is negative 1. But it doesn't matter if you want to rise 5 and run to the left 1, or if you want to go down 5 and run up 1. Because on a graph, we know that you can go in 2 different directions and end up on the same line. So let's imagine, I'm just using a very old piece of note paper because there's a graph right here, but let's imagine that this is my x-axis and this is my y-axis. Okay, so if I started here at the middle and I decided I wanted to do the rise 5, run negative 1, like the original answer we got, I would go up 5. It tells me to rise 5. 1, 2, 3, 4, 5. And then it said to run negative 1. So on this x-axis, I would be running this way. So that would be right there. But if I did it the other way, and I went down 5, and I put that negative symbol up top in my fraction, and I went down 5, and then I run just a regular 1, so it was just negative 5 over 1, it would be there. So how can these be the same, right? Well, remember, you're talking about slope. So the slope of a line, so if I were to connect those dots, and that's not a straight line at all, but imagine I connected them. This is the slope of that line. This is it. So no matter if I go up and to the left or down and to the right, I'm still going to run into the line. So that doesn't matter. The point is, for your slope, As long as one of them is negative, you can put it up top, you can put it down below, you'll run into the line the same way. What I don't want you to do is I don't want you to see this and make both of them negative for some reason, because we know that 2 negatives actually makes a positive. So understanding how your signs work is really, really important. And this is why I've harped on, it's not 2, it's -2. When we multiply 2 negatives, it's a positive. When we add 2 negatives, it's still a negative. We've done a lot of stuff with negatives and positives, so you've got to understand that. So these are both the same. If you got an answer that looked like this, but you only saw -5 as an answer choice, you should be able to realize that those are still the same thing. This can reduce to 5, and you've got to keep the negative sign. Okay, so just don't freak out when you notice that things aren't in fraction form and you got it in fraction form, or if you get it in fraction form and it works better for you to reduce it. Either or. Okay, enough of my tangent there. Let me go back into some more examples for us. Give me 1 second. Okay, so another example. And this one's going to be a good one. Find the slope of the points 2, 7, and -1, -3. Okay, and so there are also, we're going to write this on the next page, but there are 4 types of slope: positive, negative, just lost my word, undefined, and 0. And so in this example, this is what we call a negative slope because we have a negative symbol. So negative and positive are pretty self-explanatory because you can see that they're literally negative and positive. But I'll show you different types of slope in just a second. So once we have our ordered pairs, don't forget we want to label them. So this is the x in the first ordered pair. This is the y in the first ordered pair. This is the x of the second ordered pair and the y of the second ordered pair. So now that they're labeled, and that's always what you do first, always, let's plug them into our formula. It's y2 minus y1, so -3 minus 7, and then x2 minus x1, so -1 minus 2. Okay, because this is a negative minus a number, the signs are the same. I'm going to keep that sign because I'm basically adding negatives. Yes, it's subtraction, but because this is -3 and I'm subtracting, I'm continuing to move down the number line. I'm getting further into the negatives. So we can really just add them together and keep the sign. So 3 and 7 is 10, but because it's -3 and -7, our answer is -10. And -1, and some of you guys, I'm going to do this real quick. Some of you guys like to do, hold on. Never mind, I'm not going to do that. Some of you guys like to change this to a plus a negative, but that's not what's happening here. Okay, so -1 and -2 is -3. So if this is my slope, rise over run, I'm going to rise -10, which on a graph would go down, because rise just means on the y-axis. So I'm actually going to go down 10. And then for the run part, I'm going to go to the left 3, because that's negative. But 10/3 is also a correct answer, right? So I could go down and to the left, or I could go up and to the right. Just like I showed you, I'm going to end up on the same line. Because if I start at 0, 0, and I go down 10 and to the left 3, or I go up 10 and to the right 3, I'm still on the same line. Okay, in one situation, I went down and over. In the other situation, I went up and over. I'm still on the same line, that equation that has that slope. I just went a different way. So 2 negatives can make a positive. Both of these will still get you to a different place on your line, but it will still be the right slope. What I don't want you to do is get rid of just one of these Because if you get rid of just one and one's positive and one's negative, it's not going to work. You can't do that. So up here, you can keep one negative like we did. Don't make them both negative or you'll end up with a positive, and that's not what we want. So you've got to be really careful with these signs. And then one more example. Let's see what I want to do. Oh, I'm going to do this one. One more example. Sorry, today's video might be a little bit longer than normal. I apologize. So find the slope of -3, 4, 1, -2. So we're going to label them. This is x1, y1, because that's my x and my y of the first ordered pair, and then x2, y2. So my formula is y2 minus y1, and then x2 minus x1. So let's start with my y's. -2 minus 4 over 1 minus -3. This is crucial. Some of you guys would have said 1, -3, and you would have just put 1 minus 3. You cannot do that. The formula is number minus number. So if that number is a negative, you still have to put the minus symbol. The formula has a minus sign right here. It doesn't matter if the number has a negative symbol. That doesn't get to replace that. They both have to go in there. So that's going to highly affect your answer. We know that two negatives make a positive. So anytime I see two negatives side by side like that, in this situation, that doesn't become positive. They're not side by side. They have to literally have nothing in between them but just the signs. Then you can change it. So -2 minus 4, because I'm going in the same direction, I'm doing -2 and then I'm taking 4 more away. You can just add these together and keep that sign. -2 and -4 is -6, and then 1 plus 3 is 4. So this can be reduced because 2 can go into both of those numbers, so I can reduce it to 3 over 2, and it'll still be the same slope. So from my starting point, instead of going down 6 and over 4 and getting to a certain point, I can just go down 3 and over 2 and still get to a point on that line, but just not be as far down that line. So you can reduce your slope fractions. That way you don't have to move as far. You'll still get to your line. You'll still get to a point on that line. So in finding slope, what you're doing is you're taking 2 points that have been graphed and you're figuring out how much you have to move to get from one to the other. So from this point to this point, you would have to move up 10 and over 3 to get from this point to this point. That's the difference between their x values and their y values. That's what we just did. The difference in their x values, the difference in their y values, that's the slope, or that's how far away they are from each other. So, 2, 7, and -1, -3. They're that far apart. What is that slope? It's up 10 and over 3, and you'll get to the points. So slope just tells us, again, how far away those points are from each other, but it also lets us know, like, what is the steepness of that line, and how do we find it when they've given us 2 points on a graph. So now I want to flip this page over, and I'm going to show you the 4 different types of slopes that you could have. This is how you find the slopes, and then there's different types of slopes and what they look like. So on this side, I want you to title this types of slope. Okay, types of slope. So if you want to just cut your paper into 4s, I'm just going to draw a line straight down the middle. Then I'm going to draw another line straight through the middle. So my paper will end up having 4 blocks on it. Okay, and I'm going to put one type of slope in each. And there's a video, I'll probably link it, called Slope Dude. It's very annoying. It gets stuck in your head. You'll never forget. So, in this first one, I'm going to show you what a positive slope looks like. So, all of our functions, when we graph them, they will always say y equals something. And we're going to get into those equations and how we get them, but I want you to know how we find slope and the different types of slope. So if you have 2x, right, this is that m. M value, it goes right there. So any number directly in front of x, that is your slope. Always. It has to be right in front of x, and it has to be connected to it. It should look like a coefficient stuck to x, not a number by itself. So what would this look like? Well, you have your x and y axis. This is x and this is y. Remember, y tells you to rise, x tells you to run. So if I know slope is rise over run, I could put this over an imaginary 1, because we know a whole number can be a fraction over 1. This tells me to rise 2 and run 1. And that's what we just learned, was how to get these fractions from points. So if this is telling me that my slope is 2, then what I'm going to do is I'm going to rise 2 and run 1. Rise 2 and run 1. Rise 2 and run 1. And so you'll see that is a positive slope, because we read from left to right. We read books from left to right, and we read graphs from left to right. Excuse me. So if it's moving up from left to right, this line is going up, 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 then it's positive. Now again, we know that two negatives make a positive as well. So if I had decided that I wanted to go down 2 and to the left 1, which is negative on the y-axis, negative on the x-axis, right? These are negative numbers. These are positive numbers on the x-axis. 1, 2, 3, 4, 5. This is negative 1, negative 2, negative 3, negative 4, all that good stuff, which we'll get into later. I can also make this negative 2 over negative 1. Negative 2 and negative 1. Negative 2, negative 1. I'll still end up on my line. So that's why it doesn't matter if they're both negative. You can turn it into a positive. It just depends on how you want to move. Okay, let's look at an example of a negative slope. A negative slope obviously is going to be exactly the opposite. So if you had a negative symbol right up front, then you know it's going to be negative. Those are also easy to see. So this is our x-axis and our y-axis. So again, if at any point you need to pause the video if it takes you longer to do your notes, that's totally fine. I've done this for a while, so it's easy for me to write really fast. But if this was my slope here and it's telling me to go again, we can turn this into a fraction. Then it's telling me to go, always start from my origin, right? It's telling me to go down 2 and over, over 1. Gotta go positive here. Down 2 over 1. You always start off at the last dot you just drew. Down 2 over 1. Or I could make it 2 over negative 1. So it doesn't matter if I want to move the sign to the top number or the bottom number. I could go up 2 and to the left 1. Regardless, I'm still going to end up on that same line. Okay, and when we read this left to right, it's going down. The line that we graphed is going down, so that's negative. And again, if I had given you this point and this point, you could have told me that my slope is negative 2, because you would have been able to use the formula to figure that out. And then the other two are lines, which we're going to get into later as well. But I just want to kind of give you a little exposure to this right now. So zero slope is where you have y set equal to any number at all. Like there's no x over there at all. It's just y is equal to a number, which means when you graph that, you're going to, this is my x-axis, this is my y-axis. You're going to go to that point on the y-axis. So 1, 2, 3, here's 3. And you just cut right through. I'm going to do it in green. You just cut right through. That's the line. And it's called zero slope because there's no slope to this at all. It's got zero slope. It's as flat as the ground. So there's no slope at all. And the other option that you have, and this may occur, is undefined, which we hate these, but that's where x is equal to a number. So if y equaling a number cuts through the y-axis, then x equaling a number is going to cut through the x-axis. Okay, so this is my x, this is my y-axis. So on the x-axis, that looks like x. I'm going to go to -2. So if this is 0, dead center, and I go over 1, -2, then right here is where I'm going to cut through that x-axis. And that's called undefined because you can't define this slope at all. It's not. You can't do that. So those are the different types of slopes that you could have. Again, you've heard this before. You've got positive slopes, negative slopes, zero, and undefined. And that slope is that end value that's right at the front of your function. And so how do you find that? Well, there's a formula for slope. And you just plug in the ordered pairs that it gives you, and you can figure out what your slope is. But you can also figure out slope. Instead of finding it from points, you can figure it out from an equation that they give you. All you have to do is find that m value in the equation. So this equation that's given to you, I know that 2 is the slope because it's my m value. So we'll probably go over tomorrow how you find slope from an equation or from a graph. But first I want you to be able to find it from just ordered pairs on a graph. Just actually finding slope from pairs. So thank you for tuning into this really long video. I do apologize that it was over 20 minutes. I try not to make them that long. But because this was jam-packed with so much information and a lot of stuff on reviewing what slope is and how to find slope and how to see slope and what it looks like, I'm not actually going to give you any work today. But what I want you to do is leave a comment under the classroom for today. Leave a private comment on 3 things that you learned. So that'll be the only thing that I need to make sure that you made it through this video and you saw everything. So what were 3 things that you learned? Maybe it was, you learned that the x's and the y's have to line up in the formula. Maybe it was you learned about different types of slopes and you didn't really understand. Maybe you learned why 2 negatives make a positive because you're still going to end up on the slope. I mean, it can be anything, but at this point, I just need you to comment 3 things that you learned for today, not only for your attendance, but for me to make sure that you watch the video because tomorrow we're going to continue to go more in depth with this. And again, don't forget that you have a test coming up on Friday, so be sure to continue looking over your notes.